A warm welcome to one and all. I'm very happy to welcome you all for my new channel, RF Circuit Design. So, the to begin with, I'm going to give you an introduction about microwave engineering today. So, we'll go to RF basics and microwave concepts and applications and microwave hazards. So we know this EM spectrum very well. We have come across this EM spectrum, so which is giving you a range of frequency varying from 100 hertz to 1 terahertz. And here we have a category in that from where we can see that the RF and microwaves start between 300 megahertz to 300 gigahertz. So there are two category. One is RF wave, another one is a microwave. So RF wave will vary from 300 megahertz to 1 gigahertz, whereas microwaves will start to vary from 1 to 300 gigahertz. And even we have infrared, visible light, ultraviolet, and even short waves and FM wave frequencies. So to begin with, I'll go with some history of electromagnetic waves. So in 1860, James Clerk Maxwell was the first one person to formulate the Maxwell's equation, and following him, Heinrich Hertz validated the Maxwell theory, and he tried with some apparatus. He built an apparatus to verify this Maxwell's theory through some electromagnetic experiments. Later, Lord Rayleigh have started with the waveguide concepts, and he found out that there is a cutoff frequency existing in the waveguides. And Bell Labs and MIT Labs work hard to bring some development in the waveguide theory. And in 1950, strip line was invented, and 52 microstrip line was invented. And in 42, first X-band radar was built in, and then 47 transistor was invented. Then 54, the transistor technology came into existence, like silicon and then gas MOSFET. And at last, a solid state radar was built at an Expand in 1970. So this is a way how the history of microwaves varies, starting from wave equation to the expand radar. So we know where all the microwaves will be used. So microwave has a wide application. It is used in civil, military, and medical. If you come to civil, we have wireless communication, vehicle collision avoidance, and remote sensing, and aircraft safety and navigation, radar and missile guidance in military. And under medical, we have cancer, tumor directions, and medical diagnostics and therapy. So any microwave communication system, if you see, you have a transmitter and receiver. A transmitter will be having a modulating signal, a carrier signal, which is combined or modulated using a modulator. Then it goes to the amplifier, and from the amplifier, it is passed to the antenna. An antenna will put the signal into the free space. So before entering into the antenna, the impedance matching has to happen. That's a very important thing that is done by means of a network, impedance matching network, or a part of an amplifier only. That impedance matching network will be present, and it is taken care. Again, at the receiver side, the same signal whatever is transmitted will be received by another receiving antenna, and it will be again amplified, since because while transmission from that antenna to this, there will be a loss of signal. And then it goes to a down conversion part where a mixer and local oscillator is used. So the RF signal is now converted to an IF signal, and we have a filter there to filter any unwanted frequency bands, and then a demodulator to bring down the modulating phase signal back, and then it is displayed either in a display device or in a speaker. So now if we come to the properties of RF and microwaves, okay, this is a property, that is what is a greater capacity of carrying the information is possible in microwaves. So we have a large bandwidth at high frequencies, and microwaves will travel by line of sight. And for radar, especially to build a radar, we need a high frequency, since because we want a antenna size to be reduced, and antenna gain also to be a very high gain antenna should be realized. So we realize a very high gain antenna with a less smaller size only by means of operating that particular antenna at high frequency. So microwaves are very important component in radar systems. Okay, so now when we come to the definition of microwaves, the radio waves ranging from 1 gigahertz to 300 gigahertz, or some book it is referred as 3 gigahertz to 300 gigahertz, are generally known as microwaves. So signals at these frequencies will have the wavelength that range from 30 centimeter to 1 millimeter, and that special range of frequencies from 30 gigahertz to 300 gigahertz will have their wavelength in millimeter range, and thus they are called as millimeter waves. So, what are the reasons for using RF and microwaves? Is first thing is wider bandwidths due to higher frequency. Second one, smaller component size, more available in uncrowded frequency spectrum, better resolution for radars due to smaller wavelengths, lower interference due to lower signal crowdedness, higher speed of operation, higher antenna gain possible in smaller space. And when we come to the table, which this table will tell you a commercial radio frequency band, which is obtained anywhere in books and their websites, any websites. This is one table which gives you the range of frequency starting from very low to extra high frequency. Similarly, there is another table which is designated by IEEE and commercial microwave band designations. It starts from L band to G band. Frequency range starts from 1 to 220 gigahertz. So if you see the applications, we have communication, TV and radio broadcast, optical communications, radars, navigation, global positioning systems, remote sensing, and domestic and industrial applications. In that, if you see, microwaves are used in microwave ovens, microwave cloth dryer, fluid heating, moisture sensors, tank gauges, automatic door openers, etc. In medical applications, surveillance. Okay, so when we come to the application and frequency band, these are all the commonly used frequency spectrum. And we know that also FM is varying from 88 to 108, CDMA is 824 to 890 megahertz, GSM 900 is varying from 890 to 915, 935 to 960, GPS is 100 and 1575 plus or minus 10 megahertz. GSM has two frequencies, 1.7 1.71 and 1 to 1.78. Another one is 1.81 to 1.88 gigahertz, and 3G falls between 1.92 gigahertz to 1.98 gigahertz, and 2.11 to 2.17 gigahertz, and 4G is varying between 2.3 to 2.4 gigahertz. Wi-Fi also has two bands, 2.4 and 5.2, and satellite and defense uses very high frequencies. So when we come to 5G, as we know already nowadays we are being promised by having the 5G network. What is basically the advantage of 5G is 5G is expected to be faster 10 times that of the 4G. That means data download rates are expected to be 10 times than that of the 4G. And greater frequency spectrum efficiency and low latency to enable industry 4.0 and 5.0. This 5G spectrum will have two radio frequency ranges. FR1 and FR2 are the two frequency ranges. One is the upper 5G band, other one is a lower 5G band. So we have a lower 5G band called as sub 6 gigahertz range, and higher frequency 5G band is called as millimeter wave frequency range. So the frequency range 1 FR1 is varying from 450 megahertz to 6 gigahertz, which even includes LTE, and frequency range 2 is from 24.25 gigahertz to 52.6 gigahertz. So this table will give you some basic idea about how many countries have opted the higher 5G frequency bands. So USA, Korea, Japan, China, Sweden, European countries have chosen the higher 5G frequency bands in millimeter wave frequency. And when we come to lower 5G bands, even some of those countries again have chosen some lower frequency 5G bands also. And in that, now newly added is India has been added here, which has been, we have our 5G frequency lying in sub 6 gigahertz range. It varies from 3.3 to 3.4 megahertz. And when we come to this, now we'll go with some microwave components and systems what are all there now. So if you see, we have a passive microwave and we have an active microwave components and some microwave systems. Passive is nothing but we have a transmission line, antenna, power divider, coupler, filter, attenuator. Those does not require any active devices at all. Whereas active microwave components means it has to have one non-linear device like an transistor or a diode in it. An amplifier, oscillator, mixer, RF switch, phase shifter can be called as a active microwave components. Combining this passive and active microwave components, we'll have a microwave system built, that are mobile phone jammer, repeater, RFID, RF transceiver, RF energy harvesting, microwave equipment, high power microwave systems, etc. So now we'll go with microwave hazards. Since we say that there are a lot of applications we discussed, properties we discussed, but there are some hazards also due to the continuous exposure of the microwaves. So what are the continuous because of the continuous exposure of high power microwave radiations, we have some hazards, and those hazards are categorized into three types: hazards of electromagnetic radiation to personnel (HERP), hazards of electromagnetic radiation to ordnance (HERO), and hazards of electromagnetic radiation to fuel (HERF). So each one is discussing with one particular category. The first one is with respect to the biological effects in the human (HERP). HERO stands for the effect caused by the microwave radiations to the electro explosive devices. And the last one, HERF, is nothing but it's a uh, it is nothing but uh, the way how the microwave radiation affects the volatile combustibles such as vehicle fuels also. That is why the reason when we go to a petrol bunk while refill the fuel for our car, we used to get the instruction to not to switch on our phone or not to use our phone during that time. So what is this one is the based on the continuous study and observations, there has been found out that due to the continuous exposure of very higher power level of microwave radiations will cause some biological or human effects to the human body with some disorders such as cataract, skin cancer, headaches, dizziness, blood disorders, birth defects, central nervous system damage, temporary sterility, cardiovascular problems, interference, increased stress, decrease in the immune system competency. So, how does this HERP is affecting our body is when you continuously expose our body to a very extreme high power micro radiations, the energy will be directed into our body. That whichever the energy enters into our body can be scattered, reflected, or observed, and that will cause some kind of vibration, which that vibration is turning into the form of heat, and the heat cannot be properly dissipated, and it runs inside our human body only, making our body temperature to rise. This will cause at last a very bad impact. Some kind of disorders will happen for us. And hazardous to electromagnetic radiation is the unintentional triggering of electro explosive devices can happen when you have very high power radiation microwave radiation system placed near any warehouses which stores the weapon systems, etc. Even there also there won't be any mechanism to circulate or dissipate the heat generated. The last one is a hazardous of electromagnetic radiation to fuel. This also the same. It can cause the radiation can cause the accidentally igniting the fuel vapors, which can cause some explosion in the fuel storing places such as petrol bank or any tanker lorries or anywhere the storage buildings which is having the fuels accumulated. So, how do we measure these radiation hazards level? So, there are two things. The radiation hazards or the radiations which is coming out of any devices can be measured with its measuring its average power density of the particular microwave, and the second one is the specific absorption rate. It is also one figure of merit to find out the radiation exposure limits. So every microwave device will have a specific SIR, and whenever the product comes into the market, that product has to satisfy the figure of merit, this SIR. Within the limits, the value should be the radiation should be there within the SIR limit. So the SIR can be found out by sigma E squared by MD. Sigma stands for the conductivity, E is the electric field within the material, and MD is the mass density of the material. And there are some websites which gives you what is the SIR value allowed for every microwave devices. Then how do we protect ourselves from this kind of continuous exposure or the radiations? So when we are commonly being there, we should see that we try to avoid entering any room where we get a direct contact of beam of transmit antennas or going close to any microwave generators or the propagating medium. So we always see that our house is not very closely located to the cell phone towers which has huge number of antennas deployed, or we are not we see that we don't go and live nearby any microwave generators or any propagating medium. Another way, when we our work is in such a way that we work in some radar design center where do you want to test some microwave components or devices, there we can go for having a microwave absorptive suits which is made up of stainless steel. and it can be woven into a fire retardant synthetic fiber. So this suit will be helping us to prevent or will prevent us from absorbing the micro radiation to a greater extent. There is some attenuation levels for the suit, and it is depending on the frequency levels. So I hope this is giving you some idea about the introduction of microwaves, applications, properties, and hazards. So thank you.